Welcome to this lesson on the conservation of momentum in isolated systems. Momentum is a fundamental concept in physics that describes the motion of objects. In this video, we'll explore why the total momentum of a system remains constant when no external forces are acting on it. An isolated system is a system where no external forces act on the objects within it. This means that the objects inside can only interact with each other, and nothing from outside the system can influence their motion. Think of it like a closed box where the objects inside can push or pull on each other, but nothing outside the box can affect them. The law of conservation of momentum states that P initial equals P final. This means that the total momentum before any interaction between objects is exactly equal to the total momentum after the interaction. This is one of the most important principles in physics and applies to all isolated systems. Mathematically, we express this as m1v1 plus m2v2 equals m1v'1 plus m2v'2. Here, m represents mass and v represents velocity. The left side shows the momentum before interaction, where we multiply the mass of each object by its velocity and add them together. The right side shows the momentum after interaction, using the new velocities marked with prime symbols. The key point is that both sides are always equal. Momentum stays constant in isolated systems for two main reasons. First, because there are no external forces, there are no outside influences to change the total momentum of the system. Second, the internal forces between objects are equal and opposite, according to Newton's third law. When one object pushes on another, the second object pushes back with an equal force in the opposite direction. These forces cancel each other out, keeping the total momentum unchanged. Let's consider a collision between two objects. Before the collision, the two objects are moving toward each other, each with their own momentum. After the collision, the objects either bounce off each other or stick together and move as one. Regardless of what happens during the collision, the total momentum of both objects combined remains exactly the same before and after the collision. Here's the key insight. The total momentum remains constant throughout the entire collision. While the individual momentum of each object can change dramatically during the collision, when you add up all the momenta in the system, the sum always stays the same. One object might speed up while another slows down, but the total is conserved. Let's review the important points. First, conservation of momentum only applies to isolated systems where no external forces are present. Second, external forces such as friction or air resistance break the conservation of momentum because they introduce outside influences. Third, internal forces between objects in an isolated system always cancel out, which is why the total momentum remains constant. Understanding these principles is essential for analyzing collisions and interactions in physics.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.